Hello, everyone. Thank you for coming today. I'm Owen O'Malley. I've been working on Hadoop since before it became Hadoop, back in 2006. And so originally I was the architect for MapReduce, and then I was the architect for when we added security to Hadoop. And most recently I've been working in Hive. But somehow, once you become the person everyone goes to for security, then you never get out of the security role. So there are a couple of things that you really need to think about. So you need to think about what are the most important threats to your organization's data, right? What are you afraid of people doing to your data, and how are you going to protect against it? And how are they going to get to your data? Of course, with Hadoop, almost all the tools use HDFS, and so HDFS has to be the first line of defense. You have to get your HDFS story right, or everything else is broken. But you also want to make sure that you minimize the number of attack surfaces. I've talked to a lot of security groups over the years and at different corporations. And they're always very, very concerned because Hadoop has all these services. It opens up lots and lots of ports. And so they get terrified at how do I know what services are open and how they're secured. And so you need to understand what you're exposing and how to minimize that risk. So I usually start with, you need to start with a firewall around your cluster. I know some corporations don't do that. And actually, when you start small, one of the nice things about Hadoop is that when you're one group running on a small cluster, actually having a firewall is all you need. For the longest time, Yahoo just had a firewall around their cluster. They didn't have any other protections. When you have the firewall, though, then that really, really cuts down the amount of attack area that you need to worry about and defend against. Now, people have traditionally used SSH gateways, and what I mean by that is people log into a machine that's in the DMZ between the two, and they SSH in, so that's encrypted and private, and then they issue the Hadoop commands from there. There's a new project called Nox, well, relatively new. It's actually a couple of years old at this point, I guess. See, that's the problem with me being an old timer is new means it happened a couple of years ago. So, although to be fair, I keep up on the current stuff too. So Nox provides an alternative to the SSH gateway. With the SSH gateway, you have to log in using SSH, and you have to do the commands on that machine. Nox provides an HTTP gateway that lets you issue commands using HTTP and run from there. Inside your cluster, of course, everyone's using RPC. The slaves talk to both the Yarn Resource Manager and to the name node. The Nox gateway talks to the name node in the Yarn Resource Manager and the SSH gateway. Now, typically, because people don't want to use browsers on the SSH gateway, they open up a hole for HTTP to come into the name node and to the resource manager so that people can see the logs coming back there. But absolutely, you want a firewall. Now, to be fair, some companies, like I said, don't. Facebook, for example, typically leaves their clusters open. But then again, they don't turn on Kerberos security either. So they take a much more, they trust their employees not to do the wrong thing, but that gets a little challenging for most large companies. So what are the things that you need to take care of? The worst, by far, for attack vectors is if someone can get physical access to the machines. Fortunately, that is extremely rare. Most corporations have their machines locked away in a data center, and so you can't get to them physically, which leaves most of the people with remote access. Once you, that's people who don't have access to the cluster but are trying to hit it remotely. Fortunately, the firewall deals well with most of those. The gateway machines, lots of people have access to those, so those can become a vector. If people can get to the slave machines, that's more problematic, and then the master machines. Typically, the administrators don't let people log in directly to the slave machines, and certainly not to the master machines. You never want users on the master machines. Oh. Sorry, hit the wrong button. It also matters a lot about how they have access. If someone has root, they have complete access on that machine. When I was still at Yahoo, one of the managers was very upset by this. He's like, well, you have to protect against root. And there really is no way. In Unix, root has access to all of the memory. And once you have access to all the memory on a machine, even if the keys are never in the disk, you're going to have the ability to pull them out of memory. So you can't protect against root. You need to make sure that as few people have root access as possible. Hadoop administrators, on the other hand, is a slightly larger group because those are the people that are around to fix things if things go bad in Hadoop. So they are given super user access at the Hadoop level, and they can see any files in HDFS and make any changes that they need to in Yarn. And finally, there's the traditional users that are limited by Hadoop permissions. So the first, and actually by far the most typical case, is accidental damage. One of the colleges that was using Hadoop back before we added user permissions had a student who accidentally was trying to clean up their home directory and instead deleted recursively all /user. There were no permissions. It said everyone's got the rights to delete anything they want, and so he wiped out all the other students' home directories. That's not very good. We had another case at Yahoo where someone was spawning processes in their MapReduce job, and they wanted to be nice and clean them up. So they had this great little command that they forked off a command and did kill all -9 Java. If you know what that does, in Unix that says kill every process with maximum priority, and you're going to kill every process that's running Java. That does, in fact, clean up all the tasks that all the things they were trying to kill off. It also killed off all their coworkers' tasks on that machine, and the task tracker that was launching all the processes. As a result of that, we wrote the Linux task controller that actually becomes the user. So once you do that, even if they do kill all -9 Java, at least they only kill their own tasks. They don't kill any of the system tasks, and they don't kill their friends' tasks. So absolutely, the first part of security we did was against accidental damage. That's a huge, huge threat. The next one is remote access. So these are our users who don't have access to the cluster. And the primary mechanism you need to defend against that is service level authorization. Unfortunately, part of the challenge of Hadoop security is that each of the projects has a different notion of how to configure these things. And so Hortonworks bought a company last year called XA Secure, and we turned around and took all their product and made it Apache Ranger. And Apache Ranger gives you a single user interface that's a web UI that lets you define which users are allowed to access the service. That makes things much, much easier to configure and control. And again, the firewall helps protect against a lot of this kind of damage. We typically don't see very many of these kind of attacks. Now, one of the pieces that gets challenging is that root on one machine can watch all the network traffic. This is a great tool if you're trying to debug things, but it freaks out all the security groups. And our typical recommendation is that you worry about encrypting data to and from the cluster and between clusters, but you don't worry about it when you're inside of the cluster. Because if someone gets root inside of the cluster, they've already got everything that they need. And if they can have root outside the cluster relatively easily. I was working at a startup at one point, and I wanted to show the sysadmins that they had some bad security practices. So I put a Linux box that I had root for on the Ethernet and ran a program that captured all the traffic. Well, it was even worse than I was afraid of, because they had configured all the Windows machines to check for email without using encryption. That meant that all the devs were doing things on Linux, so it was fine. But all the sysadmins were sending their password in the clear every 5 minutes. So it was rather embarrassing for the IT manager. But they fixed that problem. They turned on encryption, and after that. But the take home from that is that you want to make sure that if there's an open network where people can put their own boxes that have root on those boxes, that you have encryption turned on. Now, there are some pieces that turn on encryption inside of the cluster. In particular, you can encrypt the shuffle, encrypt the data transfer from HDFS, and encrypt all the RPC. I don't recommend those in general unless you've got extreme security concerns, because they affect performance pretty negatively. If you're just doing HTTP encryption on the outside, that's relatively low cost. But if you're doing encryption on the shuffle or encryption on the data transfer, that significantly impacts your throughput. Actually, RPC encryption is also very, very expensive. All right, so that's the bad guys attacking in. Now, what happens when you've got users that are trying to access private data? Before we started the security work, there's a group at Yahoo that's called the Paranoids. You can guess what they do. They are trying to work out what they should be worried about, and how someone's going to try and get data that they shouldn't have access to. Well, Hadoop at that point was very, very user-friendly. If you wanted to be the user Joe, you did just -u Joe, and it didn't matter who you actually were, you pretended to be Joe. The users love that, by the way. As often, security and usability sometimes fight each other, but the Paranoids thought that was not good at all. They were really unhappy that people could pretend to be anyone they wanted to be. And so we added Kerberos support. So that lets you make sure that the people using the cluster are actually the people that they say they are. That also lets you get HDFS audit logs. We're doing work with the Ranger team, actually, to make the collection of the audit logs easier. But you can get those audit logs collected. One of my friends who works at LinkedIn, for example, when the LinkedIn break-in happened, part of what they wanted to do was figure out if anyone had looked at the data on Hadoop. And so they looked at the audit logs to see if anyone inappropriate had looked at the data that was stolen. And they said no. They figured out, no, in fact, that no one had been using Hadoop. It had been other systems that had been at fault. But it was good that they could check to see if the audit logs were clean or not. Now, you absolutely want to define your HDFS permissions correctly. The standard practice is that you make group directories, and you make sure that the groups have, only those groups have permission to read and write into those directories. As a backup, you also want to make sure that the users have relatively small quotas on their home directories, and the same with the temporary directories like /temp. You don't want them to be able to dump a bunch of stuff into /temp or into their home directories, because users tend to not be thinking about the fact, oh, that's world visible and it has personal information in it, but I'm just going to leave it there temporarily. So you want to make sure that they do the bulk of their work in the group directories. Now, HDFS has a couple of things that are really useful. It's got the normal user group other permissions, but we've also added ACLs so that you can add very precise control over who has access to each directory or file. The ACLs give you user control over which groups can see it, but you can also define a user-to-group mapping, or rather the sysadmins can, and that lets you say, this user is in this list of groups. So those groups don't actually have to exist in the Unix sense, they just have to exist in terms of the script. So you can actually define your own user group mapping and protect your data the way you need to protect it. We've had customers that didn't have groups in LDAP that matched what they needed in terms of roles, and so they instead implemented a mapping from users into those roles, and were able to do things exactly the way they needed to. Okay, if someone actually has physical access to your machines, which fortunately, like I said, most companies are very, very careful with, then it's pretty much hopeless. I don't know if you've seen the pictures, but people have taken computer RAM chips, and if you cool them down, you can leave them unplugged for 5 to 10 minutes and get perfect copies of the pictures that were in the computer before it got turned off. So just having it in memory is bad enough if they've got physical access to the machines. Now, there's a subcase that is easier to deal with. If the user can remove hard drives, they break into your data center and steal the hard drives out, then traditionally they would get the data that's on those drives. But because Hadoop HDFS uses the native file systems, you can actually encrypt those using LUX or one of the other encryption methods. And then if they steal the hard drive, all they get is the encrypted hard drive, and they don't get access. But mostly users don't worry about this because it's relatively rare. Actually, one of the few counterexamples is if they actually have a requirement that there's sensitive data is never landed on disk, then they'll turn on the bottom level encryption, the file system level encryption. Now, if your threat that you're worried about is that you don't want the Hadoop admins to see the data, HDFS, in particular Intel, did a lot of work to add encryption into HDFS. So this lets you do transparent encryption, and it lets you set up these encryption zones, and you're guaranteed that everything under that encryption zone will be encrypted before it's written to the underlying disk. But if you think about it, that is really only protecting you against the Hadoop admins, because root can look at the keys anyway, and the users won't have access to the files because of HDFS permissions. So all you've really protected yourself is against this in-between level of the Hadoop admins, which can be useful, and it also lets you back things up. So for example, we've got a customer that doesn't want to run in EC2 because they want to keep their data private, but they copy the data out of their Hadoop clusters locally into EC2, and they want it to be encrypted while it's in EC2 and never decrypted. So basically, they're just using it as a backup. And for them, having it encrypted in HDFS is very convenient, because then it encrypts automatically in HDFS, and when they can copy it out without decrypting it. Each file within that directory tree gets its own unique key, so that if you can read one file, you can't read any of the other files. And you basically need to, the client needs to ask for each file's key before it can decrypt it. But the client is actually doing the decryption. That's important. I've seen some architectures where they tried to take Hadoop and have some server doing all the decryption. Unfortunately, that doesn't work very well because those servers never scale as well as Hadoop does. And so if you try to send all of your data through Hadoop that's getting read in Hadoop through another service, you're going to bring that service to its knees. So that does mean that if a person reads a file once, they can still read that file later without going back for the key if they remember the key. But it does mean that they have to ask for the key for each file. Now, each zone has a master key. The nice thing is that the user never gets that master key, and they only get the unique subkey for the file. And that HDFS just stores the subkey encrypted with the master key. So without the master key, the user can't decrypt it by themselves. And without so the HDFS admin can see the encrypted keys, but they don't have the master key, so they can't actually decrypt the data. And then the users just use the or rather the HDFS client uses the subkey to decrypt it. One of the pieces that we added into Hadoop is a key provider API, because one of the critical pieces is now that you have encryption, how do you manage those keys? The keys aren't strings that are typical passwords. They're just random bytes. So you hardly want your users to be putting those into config files or something horrible like that. You want an actual key provider service. And rather than make just one and bake it into the system, we made a key provider API. And so it's easy to make third-party integrations. So if you want to if your corporation has a key provider already, you could make a connection to it and just plug the jar in, and your Hadoop will use it. It has named keys, so you say what the name of the key is, and it supports key versions and key rolling. For a lot of organizations, that's really important because you want to make sure that you don't use the same key for too long, and you want to be able to roll new keys out but still maintain the ability to decrypt the old ones. One of the interesting use cases, actually, is that a lot of the search engines are only allowed to keep PII data, personal identifiable information, for 90 days. And so one of the architectures that this supports, one of the use cases this supports, is every day you generate a new key. You write your data with that key, and then after 90 days, you delete the key so that for the first 90 days, you can decrypt the data, and after that, the data is basically unreadable. So you don't have to rewrite the data. Hadoop does have a key management server that implements this API. It's still very alpha, and I wouldn't use it in production yet. But it's definitely making progress and is moving forward. Now, how is it using encryption? The HDFS encryption uses AES. AES is the encryption standard blessed by the US government, but it was actually done as part of a competition. And all the cryptanalysts have looked at it very extensively. But one of the problems with all of the block ciphers is that you really don't want the same set of bytes to produce the same ciphertext over and over again. You really want to make it so that if you have a string of all zeros or all spaces, that they don't always show up as the same thing. Actually, a long time ago, I did an encryption program that could encrypt images, but it was just doing a single block at a time. And so what you see is that every 8 bits on the screen would produce the same pattern. So if you had a bunch of black dots, they always ended up with the same look. So you could see the image, it was just blurred out a little. That's unfortunate. So you don't want that characteristic in your encryption. So with CTS-ATR, you have an initialization vector, that's the IV, and for every 16 bytes in the file, you increment it by a counter. And that is what you encrypt with the key, NAS. Then you take the output of that and XOR it to get your ciphertext. The advantage of that is a couple of things. First, it supports, it's a streaming cipher, so you don't always get the same output. But it supports append and seek. So for example, if you had an HDFS with chain blocking mode, then if you tried to seek into a file, there'd be no way to do it other than reading from the start of the file. For HDFS, that's a non-starter. It also doesn't pad files out. A lot of the stream ciphers need to write a multiple of 16 bytes, and so you need to write everything out to 16 bytes, even if the file was a little shorter. And this avoids that because the plain text is being XORed with a ciphertext. So you can just XOR the bytes you have of the source text, and you don't need to make a whole block for the output. So both of those are really important features, and the fact that it uses an initialization vector makes it much stronger. Okay, so those handle some of the threat cases, but what if you have some files that you want to access at different level of granularities, right? You have some fields that you want everyone to be able to see, but some of your columns are things like PII, personal identifiable information, or financial or health, right? There's a lot of things where you wouldn't want people to be able to read some columns. And what you'd really like is to be able to scramble those across rows. You'd like it so that a null value looks indistinguishable from a set of values that aren't null. You'd also like to have that initialization vector. And so what you need here is column encryption. Unfortunately, we don't have that yet. We've started working on it in the ORC format. ORC is a columnar format that is supported by Hadoop. And you need to have column encryption built into the file format, which is part of why it hasn't been done yet. But like I said, it's coming soon, and it's pretty important. This shows what an ORC file looks like. You've got a footer, and then a bunch of stripes. And within each stripe, you've got the different columns. And that's part of why column encryption works very well in this, because you can't actually tell the difference of where one value starts and one value starts inside the ORC file. There's run length encoding in here and a bunch of dictionary encoding, so you can't tell very clearly. And on the other hand, I just need to have that encryption done within the file, and then just that column is hidden. That'll let you have a whole new set of use cases that aren't currently doable, which is why I think it's really important. There's another case that sometimes gets confused with column encryption, which is where you want to mask or hide the values. And this is usually done by having a user-defined function in Pig or Hive, and it's supplied by some of the third-party ones, third-party commercial companies. This one, basically, each value is encrypted separately. So you tend to get less powerful encryption, and you can still do joins on it. So for example, if you were encrypting social security numbers, you could still tell, you couldn't tell which social security was which, but you could see if there were two tables encrypted with one of these, you could tell that this social security number is exactly the same as this one. And depending on the use case, that might be okay, but that's often not okay. You don't want the user to have that kind of information at all. One of the cases that's an extension of that is some shadow security. In particular, I've seen some vendors providing encryption and masking, especially masking, that isn't based on a well-defined public standard. And you really, really want to avoid those. They may look like they've scrambled the bytes, but in practice, you really need crypto systems to be analyzed by crypto analysts, and they really need deep analysis, and they need to be public, right? That was one of the big changes that the cryptographers realized back in World War II, was that having the system be part of the secret wasn't very scalable, because the system was often available by stealing one of the decoders. And so they needed to make a system that the key is the only secret. It's actually much, much better if you have encryption where the algorithm is known, been published, been reviewed by a lot of people, and been blessed as saying, okay, this is looking good, rather than something that someone put together. For example, one of the, not to pick on Microsoft, but the Word documents used to have an encryption feature that was particularly bad. It was basically XOR with a single byte. So trying to break it, you only had to try 256 possibilities to see what it was. It looked like it was encrypted, but in practice, it only took a little bit of work to figure out how to break it open. Okay, there are definitely resources. There's the dev lists for Hadoop and for Hive. If you find a security hole, please send email to the security list. Now, you can't join the security list. The security list is for people to report problems, and so only committers are allowed on those lists. And you absolutely need to, we take those very seriously, and we will definitely get back to you and get fixes. Both of the projects. Yes? I'm sorry, which one? .org. Oh, that's funny. That's .org. Orc on the brain. I've been doing too much work on the orc format recently, clearly. So thank you. Okay, that's what I have. Do you guys have any questions? Obviously, I've been working on this area for a while, so if you have any questions about security or Hadoop, I'd love to have them. Yes?
Sorry, so actually I have two questions. The first one is regarding Embury. There is no fine-grained permissions in it. So basically you're an admin or an operator which can do almost anything on the services, or just a read-only user. Is it going to be changed soon?
I'm sorry, for which product?
Embury.
Oh, Embury? Sorry. Yeah, let's see. Actually, I'm not sure on that one. I believe that that one, they need to add the service level authorization, and they've been adding more authorization, but I don't know the timeline for when that will be added. And absolutely.
And I have another question regarding ORC or ORC. Doesn't the encryption a problem with compression? How does it fit together?
Okay, so the way that ORC works together is that the run length encoding goes first, and then the compression, and then it's written to the disk. So I interposed in between the compression and the writing to disk the encryption. So no, you compress first and then you do the encryption. Because you're right, otherwise, if you try to compress encrypted data, that doesn't work very well at all. But again, that's part of why you want the file format to be aware of the compression and the encryption so that they can be done in the right order. Absolutely. Any other questions? Oh, there's a question over there.
Well, we are actually exploring tokenization with one of our clients instead of encryption as potentially a better solution. What do you think about that, please?
Again, if the tokenization is complete, then it can work. So if for every token or every social security number that comes in, you've got a server that hands out a unique ID, that's fine. What I get worried about is if the tokenization is based on some proprietary encryption, that's where you want to be very, very careful. Actually, the other approach is that is a lot more secure in a lot of ways, is if you want to be able to do joins, which is part of what the tokenization gives you, is to encrypt the column and have a MD5 of the column on the side. Because if you do an MD5, then you get the much better safety because it is guaranteed to not change. And on the other hand, people can join on the MD5s without being able to reverse it because it's a one-way hash function. Does that make sense?
Well, we are also exploring some other security solution based notably on blocking, monitoring and blocking. So basically interactively when basically users are querying big data, Hadoop and so on, actually monitoring and based on specific criteria, blocking these queries. What do you think about it?
I'm sorry, so it's blocking the queries based on the properties of the user?
Yes, indeed.
So that can be a very powerful technique, and actually some of the Ranger work is starting to head in that direction, especially dealing with medical concerns. Some of the medical regulations are very, very precise about what you're allowed to do. So for Hive, actually, you have a few other options. You can have all the users go through Hive Server 2, and that gives you a chance to check over all the queries before they run. And so you can actually have a control point there that gives you finer grained control. If you aren't using Hive Server 2, then you have to rely on the HDFS permissions, which are obviously at the whole file level, and column encryption, which protects just columns. So you can get there, and that's probably the direction I would go, is move your users to Hive Server 2 and hook in some rules so that you can't query the tables unless define views that work correctly, and then give the permission to the users just on the views and not the underlying table. Okay. Any other questions? Oh, there. Sorry, I've got the lights in my face, so it's a little harder.
Hello. We had some trouble when giving our users access to Hive console. Because we found ourselves unable to restrict what they could do. We found that they could impersonate anyone, like in the example you mentioned earlier. And we got the impression that the Hive was, by design, it wasn't meant to be secure. So we had to resort to less comfortable means, like using a beeline client and then authentication separately?
So Hive was designed at Facebook originally. So of course, originally it didn't have any model of safety at all. That said, part of what our clients have wanted was security for Hive. And so we've gone a couple of ways. The first piece we put in was a security manager for Hive that gives you permissions on the tables, exactly matching the HDFS permission on the files underneath. So that lets you do a lot of what you need to manage it. And you know that they have the permissions that they need to execute on the file. So if they have write access to the directory for the database, they'll be able to make changes to the database. If they only have read access to the database directory, then they'll be able to read it but not write new tables there. So that actually solves the majority of the cases and actually does make it completely secure. As long as you've got Kerberos turned on, people can use the Hive CLI and only touch the tables they're allowed to do. So you probably would want to make a database per group so that they could see the tables they're supposed to see and not the tables they can't see.
Well, the problem we had is that users were able to upload plugin and define functions. So using that, they could...
All right, so we have actually addressed a lot of that. We've added, especially for users going through SQL Server, or sorry, Hive Server 2, then there are now blessed UDFs. So they can't, you can say they can't upload their own UDFs. They can only upload, they can only use the ones that are already uploaded. And that cuts them off effectively. There's also a SQL standard model with grants that actually work. Originally in Hive, you could grant yourself any permissions you wanted, which again was convenient, but not very secure. The SQL standard one has been added so that now grant is a permission itself, and you actually you need to have grant permissions in order to give yourself permissions. So then you can put your users through Hive Server 2 and actually control. They can see the views, but not the underlying table.
Thanks.
Okay, I think I'm about out of time. Or can I take one more question?
It's a short question. You mentioned the security holes. How many releases back do you provide security patches?
So for Hadoop, we will go relatively far back. Hive, it's come up far less often, and so Hive does, I don't have a good answer for that. Of course, but yes, we definitely take those very seriously and we'll push out. Once they've been released, then we will make them public with the CVE numbers. So you can actually look at the CVEs that have been caught and fixed. So you can check to make sure that your version is fixed. And please do keep us honest. If you need another version released, send us email to the security list saying, please fix it in this version. As long as it's not 1.2 or something, we can talk. If it's an really old version, then it becomes relatively painful because you'd want to fix all the versions back to that. And there have been a lot of releases. But okay, well, thank you very much for coming.